Hey everyone, I am Dr. Annie Jaji here. Today I am going to give you a brief introduction to numerical methods course. So please make sure you have already taken this ordinary differential equation before you sit for this course, because that's a prerequisite for numerical methods. Okay, so what is numerical methods? That's my first question to you. Okay, numerical here stand for approximation or another approach to solve a problem. Okay, methods here can be any other methods that you have studied in mathematics. Okay, it depends on the types of problem. So when I say problems here, okay, problems mean you can have a linear system. You can also have nonlinear system. What else you can have? You can have differentiation or derivative. I will put it problems involving derivative, and then you can okay, so problem, I'm writing it wrong, so I'll just put it derivatives problem. What else you can have? You have a problem that involve integrals, and you can also have a polynomial. And you can also have a differential equation. Okay, so these are all the problems that we wanna solve in this course, numerical methods. See, when I say all these problems, I can give you example. Okay, so for instance, if you have a linear system, okay, what is linear system? Everybody should know how to solve a linear system. So for example, I have x1 plus 2x2 equals to 5, 3x1 minus 4x2 equals to 3, let's say. Okay, how do you solve? Okay, how to solve? So you can say, let's multiply the first equation. This is equation 1, this is equation 2. Let's multiply equation 1 with 3. So I have 3x1 plus 3 times 2, 6x2 equals to 15. Okay, and then minus with the second equation. Okay, so when you do this, okay, let's move on and let's solve this. So this and this cancels out. 6, negative will be positive. 6 plus 4, 10x2 equals to 15 minus 3 is 12. So x2 equals to 12 over 10. Okay, once you have x2, I can substitute into equation 2. So my equation 2 become 3x1 minus 4. x2 is 12 over 10 equals to 3. So I have 3x1 minus 48 over 10. Let's fix this, okay, equals to 3. So 3, and I can get the solution for x1. Okay, so it's not complicated, right? It's straightforward, and most of it you've already learned, so which is good. So why we need to learn another method to solve this? That's the question now. Okay, so why we need to learn another method when you already know how to solve this by using simultaneous equation? How long did it take? Like 2 minutes? Less than 2 minutes, right? Now, how if you have a system like this? Okay, look at linear system again. How if I have a system like this? x1 plus 3x2 plus 6x3 equals to 4. 2x1 minus 3x3 2 minus 4x3 equals to 1. 4x2 plus 8x3 equals to 10. Okay, how do you solve now? We call it a 3-dimension system. How do you solve? Okay, some of you will say, do the same thing. Do the solving by simultaneous equation. Some will say, let's use elementary row operation, ERO. Fine, it works. Or you can also reduce it in a matrix form. Okay, so I can write this in a matrix form. So the following can be written as 1, 2, 0, 3, negative 3, 4, 3, negative 3, 4, 6, negative 4, 8. Okay, and then you have x1, x2, x3 equals to 4, 1, 10. Okay, so you have this system. Now you can solve it. Ax equals to b, where x equals to the inverse of a. Take the inverse matrix A. This is my matrix A. This is my matrix B, x. And this is my matrix B. Okay, so you can solve this. Fine. Now, so I still haven't answered my question. Why you need to learn numerical methods? Okay, how if you have 5-dimension system? Yeah, 5-dimension system. How do you do it? What about 10-dimension system? Things are getting complicated, right? So you need the help of numerical methods. So there is a method to solve the system. Okay, we call it Jacobi. It will be easier if we use the help of programming to solve a big dimension system. Okay, that's what we're going to learn. Okay, you'll be learning it in chapter 2. Okay, and beside this, how will you have derivative or a polynomial? Let's look at polynomial first. Okay, what is polynomial? Okay, I'll give you an example here. Okay, example of polynomial will any equation in this form: a0 plus a1x plus a2x squared plus a3x cubed plus da da da. Example, polynomial of degree 2. We have 2 plus 3x plus 4x squared, which is a quadratic equation. Okay, you can solve the quadratic equation easily. You have learned it before. What about if you have a polynomial of degree 3? That's 2 plus 5x3. You have a cubic equation. Now, how do you solve a cubic equation? Okay, there are ways that we have studied, but maybe for those who haven't studied, it will be a bit challenging. Now, how if you have a polynomial with degree 4, degree 5, degree 6? How do you solve this? So we need the help of numerical polynomial, and you'll be learning methods such as Lagrange, Hermite polynomial, Newton divided difference, and also Van der Waals matrix, and so on. Okay, now that is polynomial. Now, how if you have a system, nonlinear system? This is interesting. Nonlinear system. What is nonlinear? Okay, for instance, I have x1 plus 2x2 squared equals to 5. Why is it nonlinear? Because of the degree 2 here. Okay, because of degree 2. Now you can actually solve this if x1 is given. Okay, so to be honest, the way to write this will be, let me just change this, if something like this: x plus 2, x squared equals to 5. Okay, this is easier. Okay, can I solve this? Yeah, I can. Why not? So factor out x. I have 1 plus 2x equals to 5. So I have my x equals to 5. Or 1 plus 2x equals to 5. 2x equals to 5 minus 1, which is 4. X equals to 2. That's not that complicated. I can find x. Okay, but how if I have a nonlinear system such as this? X plus, I say system here. Let's look at scalar first, but this is not a system. This is one dimension. So we're not looking at, this is scalar. It's one dimension. Okay, so let's have it like this. Plus sine x plus exponent x2 equals to 5. How can I solve this nonlinear one dimension? It's not that easy. Not easy. But with numerical method, you can use Newton method. There are 3 methods. There's Newton, there's bisection, and there is also secant. Okay, these are the methods that you'll be learning for nonlinear scalar. Now similarly, if you have nonlinear system, okay, such that x1 plus x2 squared equals to 6, 3x1 minus 4x1 x2 equals to 5. Now this, okay, you can solve this system of equation using Newton method. Okay, so this is what we're going to learn maybe in chapter 5. Okay, so this is the summary of numerical methods that you're going to solve for certain types of flow. And also there's one thing that I didn't say. If you have a differential equation such that d over dx sine x. So how do you solve this? This is very easy, right? The answer is cos x. But how if you have a very difficult derivative that you need to solve? Now, I can also solve this using forward and central difference formula that you will learn in chapter 7. Okay? Now similarly, if you have a derivative, exponent x dx, how can I solve this? Okay? Obviously, it's not that difficult if you solve it analytically. Okay? So, but we will learn how to solve this numerically using a few methods: trapezoidal, Simpson rule, and then a midpoint rule. Okay, so this is the whole idea. What is a numerical method that you're gonna learn? So we'll keep in touch, and I'll keep sharing with you topics according to every chapter, and I'll see you in my next video. That's all.